Hello friends, in this video we're going to try to grade a Keypoint dam as was described by P.A. Yeomans in his book The Challenge of Landscape, which you can find for free online on the soilandhealth.org website. I'll put a link in the description. The book was published in 1985 and is, in my opinion, the best reference that we have on the keyline system as a whole, but also on the elements of that system, such as the many earthworks that he described. In this video we are particularly focusing on what he calls the Keypoint dam, and I want to make a very clear distinction here. There are many dams in this book and in the keyline system as a whole. There are many types of dams and we are covering many of those in this program, but there is one particular one called the Keypoint dam. So it's a very specific dam that is called the Keypoint dam, and we will try to grade this one. He has given us a lot of technical description and general description of how this dam would be built and designed. So we will use these descriptions to try and translate them into an actual grading plan. And to my knowledge, nobody has ever tried to do that before, and I myself haven't tried to do it. So you will see it now for the first time on a video. So I will include all of my mistakes as I go along and my thought process. So maybe that will be of help to you. Now, within the book, The Challenge of Landscape, we are particularly interested in this chapter. Chapter 18, Design and Construction of a Farm Dam. And he's particularly focusing on the Keypoint dam in this section. Now, if you scroll all the way down, and you will see I've kind of highlighted certain sections, I'll come back to this in a moment. He describes the different types of dams that are included in valleys. So you notice right here, he says there are 4 distinct types of valley dams. These are specific to valleys. There are many other dams that are not necessarily situated in valleys, but here he's focusing specifically on valley dams. And within those, there are 4 major types. There's the keyline dams, or the Keypoint dam, as I was calling it in the beginning of the video. So he specifically says these are located just below the key point of a primary valley. And they're also called the high dams because these are the highest dams that you can have in a valley. And they can also be situated in a saddle. So the saddle would be the absolute highest point you can possibly have a valley dam in on any landscape. Then there's the reservoir dams, which are located below the high dams or keyline dams. And you have lower valley dams, which are, I guess, close to the secondary valleys. As you can see here, he says in the lower reaches of the secondary valleys. And then you have the creek dams, which I guess are situated in secondary valleys. So we're only focusing on keyline dams in this video, and again, they can be situated at the key point of a primary valley or at the saddle, because the saddle would technically be, I guess, the first point of deposition in the landscape, and in that way, they are a key point of that valley. So we will see, based on the contour map that we have, where we can actually find the site for a dam like that. I haven't looked at the map just yet, so we will do that together. And I've read already this section several times, and I have kind of highlighted technical information that he has provided about how to build this dam or how to grade it in our software. Because I don't think he envisioned back then that we will have kind of powerful software we have right now to do all of this work. I mean, back then they could barely even find a contour map to work with. It was seen as a very kind of difficult thing to obtain, especially a high quality contour map. Like we are talking about nowadays contour maps that are 0.25 meter spacing or even better quality, and back then it would be a luxury to get something that is like 10 meter contour spacing. So things have come a long way, and we can now try to take this information that was provided for us with within the kind of context that they provided it in back then, and try to translate it to our context today. And it is a bit of a challenge because not all of the information that I would have liked to have has been provided here, but for the most part it is there. There's enough information for us to work with. He also provided us a series of drawings throughout this section, so if you scroll through, you can see these kind of build on top of each other, and I've already kind of created snippets from those and placed them in this document so I can kind of see them next to each other for easier referencing. But in terms of the actual technical information, I'm going to come back to this section, and we will go through it together and talk about how this applies to our software. because it will be different to how it applied on the ground for them back then. Because as I mentioned in the previous video on the basic dam grading process, in the software we are building things from the top down, whereas in reality we would build things from the bottom up. And so that's another way, or another thing we have to think about when we try to translate all of this. So one thing I want to bring your attention to is that the Keypoint dam specifically, as well as many of the dams in the Keyline system, should be considered a system in themselves. And it's not just the dam structure, but you can see that it includes many components. And actually, if we try to break this down right now to our basic building components, like we did in the basic dam grading video, if you remember, we are building our structures in parts. You don't try to build everything all together all at once, because it just doesn't work. It's very messy, and that's not how you'd think that you would build things in reality. If you build a house, you would build it in parts down to the nuts and bolts. These are also parts or elements of the house, and then you put all of this stuff together based on a design. And the house may include thousands of parts, and it's the same with these structures. We're trying to break them down to their building blocks, and then we are merging them all together into one single structure or system. And you could also say a house is a system, because it's an assembly of many elements that work together to create that kind of a structure that meets certain needs or provides certain utility. So if we examine this dam right here, we can see that we have the embankment right here. So this would be one part. So we can call this element number 1. Again, we're thinking about building things from the top down. So we're going to start with the embankment, as we did in the basic dam grading video. Another thing to see here is that there's also this keyline conservation drain. This is an integral part to the Keypoint dam as he described it. So there are many small details here that many people don't notice, and I'm going to try to go through those as we grade this dam. But for example, one of those is that notice how he specifically says in this section that keyline conservation drain goes all the way back around the dam, and the key point of the valley actually serves as a reference point based on which you build everything else. So we actually are going to start with the key point of the valley and build everything based on that. So our keyline water conservation drain is actually going to be number 1 on our list, and the embankment itself is actually going to be number 2. So we are going to start with the conservation drain specifically because the key point serves as the reference point based on which everything else will be built. And he specifically says that, again, the water conservation drain goes all the way around the dam, and it is built based on the key point. Many people will do something like this, where they will try to, make a drain and directly channel it into the dam. This is a bad idea, because it's going to start eroding the side of the dam right here, whereas the back side of the dam is usually the flattest point at which you can release runoff, and it is also a very convenient point for building like small wetlands or kind of settling pools that can capture any sediment that comes off with the runoff before the water actually enters the dam. So that way reduces the amount of maintenance you have to perform on this dam to keep it in good condition. Whereas if you build a channel right here at the side, it will start creating erosion most probably, and it's not a very convenient spot for creating settling pools. So it will probably increase the amount of maintenance that you have to do to this dam. Another thing that he says is that the water conservation drain ties directly with the spillway. So we know that this drain is ultimately going to reach the elevation of the full water level contour. So you can see right here, water level contour, this is the full capacity water level. And notice how the drain comes exactly at that level, and then everything transitions into the spillway. So we're going to do the exact same thing. We're going to actually base our full capacity water level off of the water conservation drain and the key point. So we're going to build this drain first, then the embankment, and afterwards we are going to build the excavation area. Another thing that, and this is something I learned from P.A. Yeomans directly, is that the excavation area tries to sink in with the shape of the valley. It's not an arbitrary shape so much, it's rather a shape that tries to synchronize with the shape of the valley. I think he did this, first of all, it kind of makes natural sense that you synchronize with your your base, the foundation on which you're building, so that you can reduce maintenance, and also I reckon it's a lot cheaper to actually do that than to just make some arbitrary excavation area shape that doesn't synchronize so well with the natural shape of the valley. And so we're also going to replicate that. So we're going to build our excavation area in a way that synchronizes with the shape of the valley. It's not going to necessarily look exactly like this here, because every landscape is different, so we have to synchronize with the landscape that we are actually working on. And another thing that is actually part of the embankment, and this will be shape 3, but notice right here there is a cutoff trench, and these are not always necessary, and even today we don't always make those, because only geotechnical investigation can really reveal if these cutoff trenches are necessary. But notice that he has it here, so we are going to include it in our plan just to pay homage to to the design of this dam, just the way it is here. And there's also a lock pipe trench. So each of those have their dimensions. Unfortunately, he didn't provide the actual dimensions for these, so I'm guessing they vary. But one way to kind of see what he was probably envisioning for those is that notice that the cutoff trench is more or less the same dimension as the crest of the embankment. So if we draw kind of vertical lines here, you can see they're more or less are matching in width. And the grading sites or the grading batters for the cutoff trench, these would be, I think, 1-to-1s or 1-to-2s. It was provided somewhere in the section of the book, if I'm not mistaken, but I'm going to verify that later. So we're going to also make these before we actually proceed any further than the excavation area. And again, we're building things from the top down. So what we're going to do first is build the embankment, and then we are actually going to build the cutoff trench, because in the software itself, it doesn't matter that we are building them top down. It's actually easier, as I tried to explain in the previous video. So we're going to do that, and later on we're going to merge all of these structures together. So the cutoff trench I'm going to include as probably as part of the embankment, but we're going to see later in the software how we're going to do this. It could be that we're also going to separate it into a separate structure. So if we look at this, maybe the cutoff trench will actually be structure number 5. So this is where the cutoff trench would come, or sorry, structure number 4. So this is probably what we're going to do. And then we're going to have the spillway. So the spillway, the way we're going to do this is, he was saying in the book that what we're going to do is an extension of the embankment usually. So notice that there is an embankment extension right here. And the reason for this is that you can release the outflow somewhere where it's safe, where the slope is kind of flatter, and so that you can protect this side of the embankment, right? So if you release the flow right here, it may start rubbing against the embankment and eroding it over time. So what we're going to do instead is try to release that flow somewhere farther away. So maybe somewhere around here. So we're going to design that. And the actual release happens through a level sill spillway. So somewhere around here, we're going to make a flat, kind of a flat section for the water to be able to be released right there without damaging anything. And other details that we may want to examine is, if we look at our document right here, we can see that he also kind of specifies here that you see the soil, the topsoil has been cleared. So they have removed this section of the valley, where the valley floor used to be, and the soil has actually been piled somewhere further away, around 50 meters or so away from the dam site, so that it can later be reused. So maybe we will try to also simulate that in our software to actually remove this topsoil layer. We don't actually know how deep the topsoil layer is on our example site, because it's just an example site, but we can kind of estimate that it's around 30 centimeters deep. So we can actually simulate that in our grading software and clear out the topsoil of the entire dam site. So everything that is within the water level area and under the embankment, we can actually clear all of that soil as well as what's in the spillway and kind of remove the top 30 centimeters of it, just to simulate that soil has been taken out. Now, let's see if there are any other details we have to think about. I'll just clean this drawing. And I forgot to mention also the lock pipe trench. We are also going to simulate that trench. So we're going to dig this out as well. And maybe there will also be a separate structure. So if we go back to our drawing right here, we will have a lock pipe trench. So our spillway will probably be structure number 6. And then the lock pipe trench right here is going to be structure number 5. Now let's see if there's anything else. I don't think there's a lot of other important details that we need to include. I think we kind of broke down the entire dam to those 6 elements. And then finally we are going to create the water level and measure that volume relative to the volume of the entire rest of the dam system after we've merged all of those elements together into a single coherent structure. Now, as we are doing all of this, I'm going to come back to this document and we're going to talk about these details here that I have highlighted. So, for example, right here is where I was talking about that he specifically says that the water conservation drain of a keyline dam has a fall right around the top level contour of the dam, meeting the water level at the floor of the spillway. So this is that detail I was trying to explain earlier. And he says a lot of these things that it kind of almost feels like they're introduced into the text as not a very important point, but they're actually crucial for the building of the rest of the dam. And even here he says shrinkage allowance in the dam should be around 10%, which is adequate for most of dams. I believe I remember in another book he said that more than 2 or so percent is too much if you actually compact the dam well, but in this book he says it's 10% is adequate, so we can use that for our calculations when we calculate the volumetrics at the end. And yeah, there are a lot of details in here, so we're just going to start doing the work now, and as we reach a certain point where we need to know the exact grading criteria, we're going to come to this document and talk about that. So with all of that said, now we can move on to QGIS to quickly find a area on a contour map that we can use for our modeling purposes.